This is video number 1 for section 6.7 and 7.1, solving equations using factoring. We're about to launch into a big study of quadratic functions and parabolas. We're going to figure out about the equations and the graphs and all that good stuff. Before we do that, though, we're going to talk a little bit about how factoring is going to help us in our study. And in this video, in particular, we're going to look at how factoring can be used to solve certain types of equations. In fact, I wrote a little sentence here to start. It says the factoring method can sometimes be used to solve equations that have natural number exponents in them. Natural numbers are numbers like 2, 3, 4, etc. If you have an equation where these sorts of exponents are present, sometimes the factoring method can help you to solve it. Here's an example problem that I can use to demonstrate this for you. And then over on the side, I've given us a list of steps for the factoring method. So let's work through those steps. This particular equation, we're being asked to solve for x. That just means get x by itself, figure out what number you would stick in here to make this equation true. Well, if you just try to play around with this using any of our normal algebra steps we've been using all semester, you're just never going to get anywhere. You have x showing up in too many places. These two guys are not like terms. There's just no simple way here to get the x by itself. By the way, this particular equation, since the highest exponent is a 2, is called a quadratic equation. Let's go ahead and try to solve it. So, factoring method, a preliminary step is if you see fractions or parentheses in the equation, they're really in your way. You want to get rid of those things as fast as you can. I don't have anything like that in this example, but if I did, I would clear the fractions or I would distribute to get rid of the parentheses. The main first step in the factoring method is maybe a strange sounding one. You have to get a 0 on one side. Or another way to say that is move all the terms over to one side so there's nothing left on the other side. In this case, that would mean subtracting 4 from both sides. I don't believe we've ever had that as a starting step in solving an equation. That would give me 2x squared plus 7x minus 4 equals 0. I suppose I could have moved these two guys onto the right side. That would be another way I could have created a 0. But I can see what's coming. I'm about to be factoring. And as we learned in the factoring lesson, it's always easier to factor if my lead coefficient is positive. So I think what we've done is the best thing to do. I've got a 0 on one side. Step 2 is factor the other side. You're going to have some kind of polynomial over here. Use the overall factoring strategy we came up with in the last lesson and go ahead and factor this. Remember, factoring just means rewriting this as a giant multiplication problem. Step 1 of factoring, pull out the GCF. I'm looking at this. I don't see a GCF, right? I don't have anything in common to all three terms I can pull out, but I need to check. Step 2 of factoring, count the terms. I have 1, 2, 3 terms over here. This is a trinomial. We learned two methods, the reverse FOIL trial and error method or the Xbox method. You can use either one. The numbers here look pretty small, so I think I'm going to be comfortable just using the trial and error, the reverse FOIL. But if you love that Xbox method, you could pause the video and try it that way yourself. As far as the reverse FOIL, let's see, I love the 2x squared at the front. I know that comes from the first term in each factor down here. There's only one way to make 2x squared. 2x times x. So that's very, very simple. Then I go to the back, the 4. The 4 is a little bit more annoying, right? Because it could be made from a 2 times 2, or it could be made from a 1 times 4. I can jot down some of those possibilities. 2 times 2, 1 times 4. I suppose it could be 4 times 1. That's really all I've got, though. And to be honest, most of these go out as possibilities immediately. Remember, I can't have a GCF in one of these factors, so since this is already a 2, I know this can't be a 2, so that option's out. Since this is a 2, I know this can't be a 4, so that option's out as well. The only one even worth trying is this, with the 1 here and the 4 here. I just need to see, can I make a 7 out of that? And yes, I think I can, because the outer here is making an 8. 2 times 4 is 8. The inner is making a 1x. Pretty confident I can make a 7x out of an 8 and a 1. I would need positive 8x minus 1x to give me that positive 7x. Okay, since this is kind of messy, let me rewrite it nicely. So my final factoring became 2x minus 1 times x plus 4. Don't forget the equals sign and the 0. Now that I've factored that side, I use what's called the zero product principle. I've written part of it here in the box. Let me fill in the rest for you. The zero product principle says this. Imagine me walking up to you and saying, hey, I'm thinking of two numbers. I'm not going to tell you what they are, but I will tell you that if I multiply those two numbers together, the answer is 0. What does that tell you about my two numbers? Well, the only way you can multiply two numbers together and get an answer of 0 is if one or both of the two numbers is 0. So the rest of this statement is, if a times b equals 0, then you know that either a equals 0 or b equals 0. That statement is called the zero product principle. The thing is, it only works for 0. If I tell you, hey, I'm thinking of two numbers, and when I multiply them, the answer is 12, that does not mean that one of the original numbers is 12. Maybe I'm doing 3 times 4. Maybe I'm doing 2 times 6. This only works for the number 0. By the way, that's the reason for step 1. You have to get this 0 on one side, or else your factoring is useless. Look at what I have now in this equation. I have two items being multiplied together. I know they're kind of complicated items. One of them is the 2x minus 1. One of them is the x plus 4. But when I multiply those two items together, the answer is 0. Well, according to the zero product principle, the only way that can possibly happen is if the first guy is 0 or if the second guy is 0, and so that's exactly what I write down. This is what you should be writing down. This is what I'll be looking for when I'm looking at your work. Once you do this, you realize, okay, now I'm home free, because now I have two simple equations where I can easily isolate the x, and that's step 4. I just need to do that a couple of times here. Obviously, add the 1, divide by 2. One of my answers turns out to be x equals 1/2, and the other one turns out to be x equals -4. One of the interesting things to note here is that I ended up with two answers. That's not normal for us. Usually we solve an equation, we get a single answer. With quadratic equations, though, where the highest exponent is a 2, it's actually pretty normal to get two answers. What we're saying here is you could plug in either one of these numbers and you would get a true statement back in the original equation. X equals 1/2 works. X equals -4 works as well. I won't take the time to show the check, but of course these are very easy problems to check. You would just go back to the original equation and one at a time stick in those x values and make sure that the equation really comes out to be true. And then one last comment, why the word sometimes up here in that original sentence? Why can factoring only be used sometimes? Maybe you've figured out why that is if you think back to this step right here. The only way that the factoring method works is after you get that 0 on one side, the polynomial that you have over here better not be prime. If it's prime, then I can't factor it, and if I can't factor, there's no way I can use the factoring method. That doesn't mean we give up. It just means we're going to need to learn some other methods. And later on in Chapter 7, we will be learning how to solve these kind of equations when the factoring method doesn't work.